À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top, allumage P80 et décollage. La propulsion est nominale. Paramètres à bord normaux.
And we're off. Sentinel 2B is on its way. Look at Vega.
Les paramètres à bord sont normaux, la trajectoire est nominale.
Blazing a trail across the equatorial skies over the Guiana Space Center, heading north out over the Atlantic. We're just getting the rumble, the sound, if you like, of the launcher here at the Mission Control Center. The job of the first 3 stages is to get us away from the Earth. Vega's pushing itself away from gravity. And we're burning the first stage. It's called the P80. That's because 80 is standing for the amount of propellant, 89 tons in fact. On the bottom left you can see our altitude is 35 kilometers above Earth. And in the middle, our distance from the pad. That's actually the distance if you were to draw a straight line from the pad to the position of the launcher along the Earth. And then on the bottom right, you can see is our speed. We're travelling nearly 2 kilometers per second, not per hour, but per second.
Acquisition de la télévision lanceur par la station de Saint-Jean. Séparation P80.
We've
Allumage du Zéphiro 23.
separated the P80 and lit the engine now on the Z23. And joining me in the commentary box here is Guido Levrini. Guido is the Copernicus Space Segment Program Manager for ESA. That means that he oversees all the Sentinel satellites. It's great to have you with us. Thank you very much indeed, Guido.
Thank you for having me.
Guido, you also know quite a bit about Vega. And although it was developed by ESA, it actually started out as an Italian project, didn't it?
Not quite, not that completely. Vega grew out of joint cooperation between the US and Italy back in the 70s. It was a project called Scout. It was launching from a base off the coast of Kenya, near the equator. And at a certain point in time, in 1992, the US withdrew from this cooperation, and Italy continued alone on a new program called Zefiro. And Zefiro in Italian is the name of a wind, and it was based on the carbon fiber technology. And Vega, which in Italian stands for Vettore Europeo di Generazione Avanzata, or Advanced Generation European Vehicle, is a launcher developed by the European Space Agency. So it's an ESA project, but you're right, the prime contractor is Italian, is ELV, which is a joint venture between the Italian Space Agency and Avio, who is a company based in the south of Rome.
And right now we are flying like the wind, burning the Z for Zefiro, second stage, and now about to switch on the Z9, Zefiro 9. My pronunciation is probably a bit wrong. I think it's Zefiro in Italian.
Zefiro.
And the next phase, separation of the fairing, which we don't need anymore because we are 131 kilometers above our planet, and we don't need it because there's hardly any friction. Vega's going from strength to strength. Let's hear from the CEO of Avio.
Vega has set a world record in terms of accuracy and reliability, with 8 perfect launches in a row from the maiden flight in February 2012, exactly 5 years ago. Vega has demonstrated a unique ability to deploy satellites in multiple orbital planes with unprecedented orbital maneuvers. Vega is the smallest of the European launchers family operated by Arianespace. Vega was developed by Avio as the industrial prime and is manufactured at 65% in Italy, and for the rest across Europe by a team of selected and capable industrial partners. I'm speaking to you from our plant in Colleferro, where we produce Vega, and we are now developing Vega C, which will fly for the first time in 2019. Behind me, you see the production of the first carbon fiber motor case of the P120C, the solid rocket motor which will equip both Vega C and Ariane 6. This will be the world's largest monolithic solid rocket motor manufactured in carbon fiber. It is nearly 12 meters long, has a diameter of 3.4 meters, and contains 142 tons of propellant. Today, Vega will take to space Sentinel-2B, one of the satellites of the European constellation Copernicus. The Avio team, together with its industrial partners, Arianespace and the European Space Agency, had once again a chance to demonstrate the strength of Europe's space strategy, which hinges around our close collaboration and teaming. I therefore wish the best success to the 9th mission of Vega.
Interestingly, the carbon fiber that he mentioned there was used in a spin-off to build some great big structures inside. We have separation of the Z9 inside ITER, which is a nuclear fusion experiment. So our flight path, Guido, takes us north. Where are we going to be flying over?
We are actually flying at the moment over the Caribbean, and we will soon go over Canada, then over the Arctic, and then we will come down on the other side of the Earth. We will coast the, let's say, East Asia coast, and finally we will go over Australia, where we will separate our satellite. This will happen 58 minutes into the flight.
And the range operations manager is confirming there that we picked up the signal at the Bermuda tracking station. That's in the Caribbean, one of the Caribbean islands in the north of the Caribbean. So we are now flying over the Caribbean. Why are we flying north, Guido?
Sentinel-2 is an Earth observation satellite, and these satellites are usually placed on an orbit that goes over the poles. This because, being on such an orbit, you exploit the rotation of the Earth underneath to image the whole Earth. You have to imagine that you're peeling an orange, and stripe after stripe you are peeling it completely. And these stripes, in the case of Sentinel-2B, are very, very wide, almost 300 kilometers, and this is what allows us to image the whole Earth with one satellite every 10 days, and now with 2 satellites every 5 days. And at our latitude, our meaning European latitude, every 3 days. There is no other system in the world that has this performance.
Premier allumage de la VUM.
So, Avon, the upper stage, has switched on its engine. That's going to burn for 7 minutes. So we've started the next phase of the journey because Avon has, well, effectively taken the wheel, as it were.
Yes, it's his job now to deliver the spacecraft to the drop-off points at almost 800 kilometers, but this will go in steps. This will happen only in about 15 minutes from now.